Next, for some circle problems. So in this diagram, we have circle O, and CD is parallel to the diameter, where the measure of this arc is 130. C to D is like 130. Well, what would the measure of A to C be? Well, if we need to think of this as 180, for the full 360 when you have two of those, what would that leave for this little remainder here? If we need 180 and we already have 130, then we're missing 50 from the two sides. One side would then be half of 50, or 25. And just like that, we already have choice A. Now, in the bottom problem, we have this circle whose GO length is 8, and the measure of our angle is 60. What would the area be then in terms of pi of this shaded region? Well, what is the area of a circle? We know cherry pies are delicious. Well, we know cherry pie is delicious, and apple pies are too. A, the area, is pi times r squared. The radius is 8. So the area of the full circle would be pi times 8 squared, or 64 pi. That's good and all, but we're not dealing with the full circle. We're dealing with a portion of it. So what portion do we have, or what's missing? Well, if we think about a circle, and we think about 180 degrees, or let's say 90 degrees, or 60 degrees, what portion of the circle is that 60 degrees cutting out? So we could have 60 and then another 60 to be 120, and then a third 60 to be 180. So we know that 60 degrees is taking out one of these top thirds. If we consider the full circle, and we were to make this cut here, and that cut there, along with our diameter, 1 piece, 2 piece, 3 piece, 4, 5, and 6. So out of the 6 slices, we have 1, 2, and then we have 3 on the bottom, where 2 and 3 make 5. So we have 5 out of 6 pieces. Finally, if we're dealing with an area for the full circle of 64 pi, and now we're reducing it by 5/6, well, we can just do this out. So 64 and 6 have 2 in common, so why don't we do 32 times 5 pi over 3, where 32 times 5 would have to be 160. So 160 pi over 3. Choice D.